the keratin hydrolysate. In this keratin isolate, this is an essential or a very traditionally used method. In initial stage, they have isolated this cysteine from any of the human or animal or from the birds. They have collected some of the feathers and also the hairs, and then they underwent some of the acidic by using some of the hydrochloric acid, concentrated hydrochloric acid, and they lysis, and exactly they extracted the cysteine. But for the commercialized production or demand of the cysteine, they can able to get only if they have used only 1 ton of hair, only 100 kgs of cysteine have been extracted. So for that reason, they went for many alternative methods like a bioconversion or a fermentation process. Okay, so we can see in China they have been isolated the cysteine from feathers, and also this cysteine have very unpleasant, and also yield is very low when compared to the normal conversion method and all, and wastewater treatment is also very difficult for them. So they by directly utilizing the conversion of all the present in the medium into some other component, like that it have been same, the biosynthesis will be there, no, same like the conversion will happen. So initially in the medium itself they have DL-ATC, which is nothing but DL2 amino delta square thiazoline 4 carboxylic acid have been converted into cysteine with the help of an Pseudomonas species. Okay, by this method it is very good yield have been obtained, so they went for this approach. Okay, but they require 3 different types of enzymes. One is like ATC rasmase enzyme, and L-ATC hydrolase enzyme, and another one is S-carbamyl L-cysteine hydrolase amine. These enzymes are very essential for the conversion process. So as we know that in each and every steps that requires changes. So first in enzymatic recovery of D to L, it requires the first enzyme, and then the L-ATC will be converted into L-NCC, and then this L-NCC have been converted into cysteine. This is the exactly the whole process of the enzymatic bioconversion. So in enzymatic method we can say any of the chemical composition present in the media will be completely converted into some other compound with the help of a microorganism, we can say it. And if it is using in a bioreactor, the recovery and finishing is a whole like a production process and a commercialization. And then we will move on to the fermentation process. The high production of cysteine have been obtained by using some of the bacterial strains, and also some of genetically modified microorganisms are being used for the commercialization production. This approach is very good when compared to the either chemical conversion or keratin hydrolase conversion. Especially there is a chemical company, they are going for this industrial production of cysteine through fermentation process. So Wacker fine chemical have been going for this production and all, and the obtained cysteine is almost 90% pure. It is very pure in quality, and so that it can be used for the food industries and also pharmaceutical industries for further productions. They will directly use this system. Then when it comes to a biosynthesis, so how exactly it has been converted. In industries they are going for either the animal as a raw material, animal sources as a raw material, or plant sources as a raw material. The exact conversion will be based upon the sulfur components present in it, and the sulfur, that is methionine, is also one of the amino acids, and it will be converted into homocysteine. This homocysteine will undergo an intermediate stage which is called as adenosyl methionine, and this methionine will be further converted with the help of an enzyme which is called as cystathionine beta synthase, and this will be converted as a product thioether cystathionine, and this will be further converted into cysteine as well as the alpha ketobutyrate. These are the enzymes presented. And in some of the plant and bacterial conversion, we can say, like it starts from the serine, it will be converted into O-acetyl serine by an enzyme SAT, which is called as serine transacetylase, and this will be converted into further ester, and then this ester will be converted by using an enzyme cysteine synthetase, and the final product will be cysteine. Okay. This is the exact conversion of, you can already, I have told you all the exact reactions type. So we can say we already have been seen for the bioconversion methods and all in lactic acid or in acetic acid reactions. So how exactly will be the main source will be the glycolysis pathway, and also citric acid pathway and all. Only based upon this, most of the amino acids have been produced. Okay. And if it comes to the cysteine, like in glycolysis pathway, when it reaches the 6-phosphoglycerate stage, from there the serine will be converted. This serine will undergo acetyl serine, and then cysteine will be obtained. So this is the top part on the left side will be exactly the production or bioconversion of your cysteine. Okay. Even also many other amino acids are being converted by using this basically this glycolysis pathway. From there on, each and every step, the conversion may vary based upon the presence of the enzymes in the which have been produced by the amino acids mechanism. Okay, then we will move on to the main conversion. Like L cysteine is the top precursor, which will be undergo a conversion of L cysteine, and if they are going for any genetically modified organism, then they will check whether which gene can encode the serine producing enzyme. That gene have been enhanced or produced, and so that the microorganism will have a very good conversion of this serine into a cysteine. Okay, this is what the exact production is going on inside the genetically modified organism. So once the production is over, there are few downstream processing, which is like centrifugation, filtration method, crystallization method, ion exchange method, or electrodialysis method, or solvent extraction, decolorization, and evaporation method. By achieving these downstream processing, we can able to get 90% pure cysteine can be obtained when compared to the keratin hydrolysate or else enzyme bioconversion method. Okay. So these are the main thing. What are the raw materials required for the production, for when it comes to an commercialization production. The extraction from the protein hydrolase, it is a normal keratin process, means it's only required a human hair and animal feathers. Then it are being extracted by using concentrated sulfuric acid. So the keratinase protein in the human hair and also the feather have been extracted, and the cysteine have been produced. Okay. So the bioconversion by using pseudomonas species, we can say, like I already told you, DL2 amino delta square thiazoline 4-carboxylic acid. This will be converted into L cysteine. So this L cysteine process required 3 different enzymes. We already saw in the previous slides also. So these 3 different stages will be occur, D to L, and then L to LNCC, and LNCC will be converted into cysteine. So when it comes to biosynthesis, if you are going for the Corynebacterium glutamicum, then the basic synthesis will be very good in 3 different pathways. One is that this will 2-methionine biosynthesis pathway, and then it will undergo the SAT and also OS, which will be partially synthesize this very pure form of cysteine will be about the cysteine. So these are the production area for the cystine. Thank you.